Hello all, welcome to the Counting Well RMS Prep live session. We know that the baseline for RMS, that is Ramanujan Math Scholarship, is already released and we have the final assessment test on 30th April. How to participate? You just have to complete the course in step 1 of the RMS in order to qualify and take the scholarship. The course is designed to help you fill any learning gap from previous academic year and get you prepared for the new class. So we are here to help you qualify the scholarship. For this, stay tuned to the session and get ready for the test. Well, before we start the session, let us see a problem posted by our app user Akshat Anand from Ryan International School. So his doubt is on the problems of algebra chapter. So as we are going to revise or we are going to glance through some of the topics. So today's our chapters are exponents and powers, geometry and algebra. So Akshat, stay tuned to our session and get your doubts cleared. Let us see what are exponents. Okay. Let us consider one event. It is Rishabh's birthday and he has 5 best friends. And he wants to give his friends chocolates in such a way that first friend gets 2 chocolates, second one gets a double the number of chocolates the first friend gets. So he will be getting 2 chocolates. Third friend will get the double of what second one is getting. So 4 into 2 is equal to 8. Similarly, fourth friend will get 16 chocolates. Fifth will get 32 chocolates. Let us observe the table on the number of chocolates. So first friend will get 2 chocolates. So we have 2. Second friend will get 2 into 2, which is 4. Third friend will get 2 into 2 into 2, which is 8. And fourth friend will get 16 and 32. Here you can see how 2, 4. So here you can see this 2 multiplied by 2 will get 4. Then this 4 is nothing but 2 into 2. It's multiplied by 2. The next one will get double the number of chocolates here. So we have 8. 8 into 2 is 16. But 8 is nothing but 2 into 2 into 2. So 32 is nothing but 2 how many times? We have 2 5 times, correct? So just like how repeated addition is expressed as multiplication. So if we add 2 2 times, it means it is 2 times 2. If we add 2 3 times, so it is nothing but 2 times 3 times 2. Okay. Or if we are adding 2 4 times, so it is nothing but 4 times 2. Similarly, repeated multiplication is expressed as powers. So we have 2 into 2 is 2 to the power 2. Then 2 into 2 into 2 is 2 to the power 3. 2 into 2 into 2 into 2 is 2 to the power 4. If we consider 2 to the power 4, here 2 is nothing but the base and 4 is nothing but the exponent. Now let us discover the product rule of exponents. So whenever you are simplifying exponents, you have to use some rules. So one of the rules is the product rule. So when do we use product rule? When the product of 2 or more powers have the same base with varying or same exponents, we add the exponents of the base. So what is the main thing here? The power should have the same base. Okay. For example, in general, what we can say, for a non-zero integer a and whole numbers m and n, we have a to the power m into b into a to the power n is equal to a to the power m plus n. Here you can see the base is same, that is both are a, and the exponents are different, that is m and n. So when we are multiplying a raised to m and a raised to n, that is product of two powers here having same base, we are just going to add the exponent, that is m and n. Let us see one example. 6 to the power 5 into 6 to the power of 20. So the base is same, that is 6. So we'll write 6 and we'll add 5 and 20. So we'll get 6 to the power 25. Now let us simplify one more expression, which is minus 55 raised to 7 into minus 55 raised to 70 into minus 55 raised to 3, and write this in exponential form. So you can see the common base of the three terms, that is minus 55. So we can apply here the product law, but here we have three terms. So we have three whole numbers LMN. So we have 7, 70 and 3. So if we multiply these three terms, what we'll get, this base will be the same number, so minus 55. And then we are going to add the exponent. So 7 plus 70 plus 3. So that will give you 80. So in this way, you can multiply or take the product of three exponents as well. Now let us discover the quotient rule. So what is quotient rule? When we are having powers with same base and we are dividing them, we simply subtract the exponents to simplify the expression. So when you are taking product, you have to multiply. Okay, when you are taking product of the powers with same base, you have to add the exponents. But when you are taking the division of the powers, in that case you have to subtract the exponents. But the only important thing you have to remember is they should have the same base. So for an integer a and whole numbers m and n, a to the power m divided by a to the power n is equal to a to the power m minus n. Let us see one example. 5 to the power 8 divided by 5 to the power 7 is 5 to the power 8 minus 7, which is equal to 5. Or 5 to the power 1, 8 minus 7 is 1, so this is nothing but 5. So let us see one more example. Let us simplify 10 to the power 20 divided by 10 to the power 2. So this rule is known as quotient law of exponents. So what we are going to do, we are going to take the difference of the powers or the exponents. 20 minus 2, which is 18. So we have 10 to the power 18. Now let us discover one more rule, which is called the power rule of exponent. So for any non-integer, non-zero integer a to the power m and whole to the power n is equal to a to the power m into n. So when you are taking the power of a power, okay, so in that case the powers should get, or we can say the exponents basically should get multiplied. To understand this more, let us see one example. 6 to the power 4 is raised to the power 5. So what we are going to do, 4 into 5, which is 20. So it is 6 to the power 20. Let us see one more example. Let us simplify this exponent or simplify this power. By the power law, what we can say? Minus 45 to the power 12 to the power 3. We are just going to multiply 12 and 3. So we have 36. So minus 45 raised to 36. Note that the negative base raised to the power of an even number gives a positive number. So if you find this value, what will be the resulting number? I mean, what will be the sign of the resulting number? Will it be positive number or negative number? It will be positive, because the power of an even number gives you a positive number. So when the power is even, so if you have here 36 or raised to the power 38 or 40, that is even number, power of even number, then you will get the positive number as a resulting answer. Now let us discover how to express the larger numbers in standard form. The standard form of a number is expressed as decimal number between 1 and 10, including 1 multiplied by a power of 10. To understand this more, let us see one example. So here you can see a number 176. What we are going to do, we are going to represent this number in standard form. So first convert this number as a decimal number between 1 and 10. So it should be greater than 1 but less than 10. Okay. So what we are having, 1.76. And as we are taking decimal point here, that is after 2 digits from the right hand side, so we have 10 to the power of 2. So this is how we are going to represent any number in standard form. A into 10 to the power or 10 raised to n, where a must lie between 1 and 10, and this n, which is called the index, the power of 10 you multiply by in order to return to the original number. So if you do this or represent a number like this, both the numbers will be same, but this will be called as the standard form of that number. For example, if you want to write 42,000 in standard form, it can be written as 4.0. So here you are using the decimal point, that is after 3 digits. Okay, after 4 digits from the right. So you have to take 10 to the power of 4 or 10 raised to 4, because 10 raised to 4 is nothing but 10,000, and 4.2 into 10,000 will give you the same number. Correct? Now let us write the standard form of 1996. So these are the steps we are following one by one. We are shifting the decimal point to the left side and taking the power. Where are we going to stop? We are going to stop when the A is lying between 1 and 10. So this will be our A, and 10 to the power of 3. So the index should be a whole number. So this one is correct or this one is correct? This one is correct, because it should lie between 1 and 10. So this is not acceptable, or this is not the standard form of 1996. So 1.996 into 10 to the power 3 is the standard form of the number 1996. Note that there are different ways also we can represent the same number, but these are not standard forms, because the value of A here is not lying between 1 and 10. So here it is less than 1. Here it is greater than 10. Here also it is greater than 10. Let us see one more example. The standard form of the number appearing in the statement. So we have here a statement which is expressing a large number. So the distance between Earth and Moon is, you can see how large is the number. So how we are going to write it as? So first we consider the decimal point is to the extreme right of the number. Then we are going to shift to the left by how many digits till we get a number lying between 1 and 10. So if you put the decimal point here after 3, how many digits? 1, 2, 3, 4, 5, 6, 7, 8. So you should write 10 to the power 8. Unit will not get changed here. Let us see one more example. The mass of the earth is given in kgs. Now, to read this number also, it will take a lot of time. So in this way, expressing a number in exponential form is very useful. So let us see how the standard form of the given number can be written. So we are shifting the decimal from the extreme right to the digit before 9. So we are putting the decimal dot between or decimal point between 5 and 9. So we have 5.976 into 10 to the power 24. So how many times there are zeros? There are 24 zeros. Okay. So if you see, there are 24 zeros. That's why we have put 10 to the power 24. Now, a number which is in standard form can also be converted back to its usual form. So, for example, you consider this number which is in standard form. Note that 5.5 is between 1 and 10, and we have 10 to the power 2. If you multiply this, then it will be equivalent to 550, or it will give you 550. Let us see one more example. 4.397 into 10 to the power 3. In usual form, we do not have exponents, okay? So we are writing without taking power of 10. So what we are going to do, 10 to the power 3 is nothing but 1000. We are going to multiply 1000 to this number. So 4397 is in the usual form. Now, how to simplify expressions with exponential numbers? What will be the strategy? Of course, we are going to use the laws of exponents to find out the unknown quantity or unknown exponents in the equation. So here we are not going to simplify an expression. We are dealing with an equation having an unknown quantity p. Okay. So instead of expressions, I can say these are the equations with exponential numbers. We know the difference between expression and equation. Equation is a mathematical statement having equality sign, and that equation can contain variables or the unknown quantities. So let us find the value of p for which this equation is satisfied. Let us solve this step by step. First, what we are going to use? We are going to use the product law. Why? Because here we can see the base is same for all the three terms. So 10 by 11 is the base, and we are taking the product, so it's nothing but product law of exponents. So we have to take product 5 into 2p minus 6. Are we going to do 5 into, or we are going to add them? Yes, we are going to add them. Whenever we are taking the product of powers with same base, you are going to add the exponents. So you have to add 5 plus 2p minus 6. So adding the like terms, so 5 minus 6 will be minus 1. So we have 2p minus 1. But this is given to be equal to 10 by 11 by 5. Okay. So let us equate both the terms. So we have 10 by 11 2p minus 1 is equal to 10 by 11 to the power 5. Now the powers have the same base, so the exponents must be equal. So you can see the base for both the terms on LHS and RHS are same. So what about the exponents? They should also be same. So we'll equate 2p minus 1 with 5. So 2p is equal to, we will transpose minus 1 to RHS. So we'll get 2p is equal to 6. So we have p equals to 3. Now let us go to our next chapter, which is geometry. Let us Find difference between a line and a curve, an open curve and a closed curve. So we'll go one by one. Let us see what is a straight line or a line. If we have a point moving in only one direction, then what will be the path traced by that point? It will be a straight line. It's very simple to understand. And what will happen if the moving point changes its direction? What do we get? Yes, we get a curved line. So this is what we have difference between a line and a curve, or curved line or a straight line. Curved line and straight line. So if a point moves in a one direction, the path traced by the point is a straight line. And if the point changes its direction when it is moving, then the path traced is a curved line. So you can have geometrical figures with straight lines as well as curved lines. So what are the geometrical figures with straight lines? Yes, it can be a rectangle, square. With curved line, we have circle, correct? In general, these are nothing but curves. Now let us differentiate a line from a curve. And then an open curve from a closed curve. We saw how a line is different from a curve. Now let us see how open curve is different from a closed curve. First of all, what is a simple curve? It is a curve that does not cross itself. For example, here you can see the two geometrical figures. Both are curves made up of curved lines. The curve is not crossing itself, correct? So it is a simple curve. What is a closed curve? A curve whose endpoints are not fixed, or a curve that does not have two different endpoints. So here you can see we have two examples showing closed curve. Here for the first shape, you cannot find any endpoint, or we cannot see two different endpoints. So from where it is getting started and where it ends, we cannot predict. Same for the second curve. So both are closed curve. What is an open curve? It is a curve whose endpoints are fixed, or a curve that has two different endpoints. For example, the one shown here. So here you can see there are two endpoints, 1 and 2. Same for the second figure, we have two endpoints. Now let us name opposite and adjacent angles, vertices and sides of a quadrilateral. First of all, what is a quadrilateral? It is a polygon with four sides. What is a polygon? It is a figure made up of line segments only. So a square is a polygon, a rectangle is a polygon, but a circle is not a polygon. So when a polygon is having four sides, we say it as a quadrilateral. We call it as a quadrilateral. In quadrilateral ABCD as shown here, how many vertices a quadrilateral has? It has four vertices. So for quadrilateral ABCD, we have A, B, C, and D as the four vertices. AB, BC, CD, and AD are the four sides. Let us find the adjacent angles out of these four angles. So adjacent are angle A and angle B, then angle B and angle C, angle C and angle D, and angle A and angle D. So the adjacent angles are joined by sides, okay, joined by lines, okay. What about opposite angles? Opposite angles are angle A and angle C, both are opposite to each other, and angle D and angle B. Now let us state and verify the Pythagoras property for a right angle triangle. For this, first let us consider a right angle triangle ABC. Here you can see right angle triangle ABC, correct? Now we have some special names for the sides of this right angle triangle. The side opposite to the right angle, here you can see the side opposite to right angle B. So it is nothing but called as the hypotenuse of the right angle triangle. So here we have AC as the hypotenuse of the right angle triangle. Next we have the other two sides of the triangle, which are called the legs of the right angle triangle. So AB and BC are the legs of the right angle triangle. Let us move to our next step. In right angle triangle, the square of the hypotenuse is equal to the sum of the squares of its legs. So for right angle triangle XYZ, we have xz square is equal to xy square plus yz square. This is nothing but the Pythagoras theorem or Pythagoras property for a right angled triangle. Let us watch one video to understand this and verify the Pythagoras property.
In this video, we will understand what is the Pythagoras property of right-angled triangles. Let us consider the right-angled triangle PQR, which is right-angled at Q, with sides PQ is equal to 4 centimeters, QR is equal to 3 centimeters, and PR is equal to 5 centimeters. In the given triangle PQR, PQ and QR are the legs and PR is the hypotenuse of the right-angled triangle. Let us observe an important relation between the sides of a right-angled triangle. Let us draw a square of side 4 centimeters on side PQ, square of side 3 centimeters on side QR, and square of side 5 centimeters on side PR. Now, let us find the area of each square. We know that area of a square is side multiplied by side, that is, the square of its side. So, area of the square with side 3 centimeters is 3 centimeters multiplied by 3 centimeters, which is 9 centimeters square. Similarly, area of the square with side 4 centimeters is 4 centimeters multiplied by 4 centimeters, which is 16 centimeters square. And area of the square with side 5 centimeter is 5 centimeters multiplied by 5 centimeters, which is 25 centimeters square. Let us add the squares of the legs of the triangle. That is 9 centimeters square plus 16 centimeters square, which is equal to 25 centimeters square. And square of the length of the hypotenuse is 25 centimeters square. We see that the square of the hypotenuse is equal to the sum of the squares of the other two sides or legs. That is, we can arrange the area of square 3 centimeters and area of square 4 centimeters in the area of square 5 centimeters. It means that area of square of 5 centimeters is equal to sum of the area of squares 3 centimeters and 4 centimeters. From this, we can write it as PR square is equal to the sum of the squares of sides PQ and QR. In general, we can say that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of its legs. This is known as Pythagoras property. Let us conclude. In a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of its legs.
I hope that the verification of Pythagoras property for a right angle triangle is clear now. Let us move towards our conclusion. So the side opposite to the right angle is called the hypotenuse, and the other two sides are known as the legs of the right angle triangle. And what does the Pythagoras property say? It says the square of the hypotenuse is equal to the sum of the square of its legs. Now let us start off the chapter algebra. Let us describe what are monomials, binomials, trinomials, and polynomials with the help of some properties. So, what are monomial, binomial, trinomials? They are algebraic expressions. And we are classifying algebraic expressions depending on the number of terms that expression has. A monomial, the word mono stands for one. So, it is an algebraic expression with only one term. For example, x 2 minus 3y square, etc. So, here you can see a variable x is considered as monomial, or a constant number 2, it is also considered as a monomial, or a combination of numeral coefficient and variable coefficient, that is minus 3 and y square. So you can see you can take powers of the variables as well. So x 2 minus 3 y square, etc. can be considered as monomial expression. What is a binomial expression? It is expression with two unlike terms, because if we have two like terms and we have some operations on those like terms, then either we can add them or subtract them depending on the operation given. So here you can see there are two terms. One is variable term and one is constant term. Since we cannot add these two, or these two are unlike terms, so we have two terms in this algebraic expression. Hence t plus 1 is a binomial. Again, for one more example, we can see 2 minus y square. Here 2 is a constant and y square is a variable. So the combination of a constant and variable, or power of a variable, along with addition or subtraction. Here we have used subtraction. So this is again a binomial. Here also there are two terms for the third example, and combine using the operation addition, and both terms are unlike. So it is a binomial. Next, a trinomial. The word tri and here bi itself represents its meaning. So bi stands for 2, so we have 2 unlike. Tri stands for 3, so we have 3 unlike terms. So a trinomial is an algebraic expression with 3 unlike terms. So we have t cube plus t plus 1. Then we have y cube minus y square plus 2y. Then we have minus 3x square plus x minus 5. Note that for the first example, we have 3 terms, correct? And these 3 terms are unlike, so we cannot add them. We can simply write using addition sign, correct? So it is a trinomial. What is a polynomial? Polynomial is in general an algebraic expression with one or more terms, correct? So a monomial is also polynomial. Binomial, trinomial are all polynomials. So these are the types of polynomials we can see. So we can see a monomial, binomial, and here we have trinomial, and here we have 4 terms. So we don't have special name for algebraic expression having 4 terms, but we can include it in the category polynomial. Now let us see how to add like terms. For this, you should write the terms to be added together with addition operation. Okay. Then you have to add the numerical coefficients, and then you have to take the resulting addition by taking the sum of the numerical coefficient of the given like terms. Let us see one example to understand this. Let us add the terms 5x square y and 8x square y. So let us first identify what are the numerical coefficients here. So for the first term, the numerical coefficient is 5. For the second term, the numerical coefficient is 8. Both are like terms, correct? Because it has same variable coefficient or the same, we can say variable terms. So we have x square y here also, and we have here x square y in the for the second expression also. So what we are going to do to add these two, we are going to add the numerical coefficient and take the variable coefficient as it is. So 5 plus 8 will be 13. So the sum is 13x square y. Okay, so the sum of the terms 5x square y and 8x square y is 13x square y. Now, let us see how to subtract like terms. So, first you have to write the term from which the other term has to be subtracted, followed by a minus sign, and then write the term to be subtracted. Then you have to subtract the numerical coefficients. The result will be a like term with the numerical coefficient equal to the difference of the numerical coefficients of the given like terms. Let us see one example to understand this properly. Let us subtract the term 2x square y from 10x square y. Note that both are like terms with difference in the numerical coefficients. So what we are going to subtract? We are going to subtract 2x square y from 10x square y. So we have to write 10x square y minus 2x square y. Correct? So 10x square y minus 2x square y. The difference of numerical coefficients is 8, and then we are going to write x square y as it is. Now, to find the value of an expression by substituting the given value of the variable, what are the steps we are going to follow? We have to perform the operations according to the given expression. Then the value obtained after the calculation will give you the value of the expression. Let us see one example. Let us find the value of the expression 9 plus x at x equals to minus 3. So what is given here? One expression is given. So this expression is nothing but a binomial expression because it has two terms, and the variable or the unknown here is x. So if you put x equals to minus 3, what will be the value of the expression? Just have to substitute x equals to minus 3 in the given expression. So x plus minus 3, so it will be x or 9 plus minus 3. So 9 plus x will be 9 plus minus 3, which is 6. Hence the value of expression 9 plus x at x equals to minus 3 is 6. Now let us see how to solve given equations by transpose method. So what is transpose method basically? For example, you are given one equation ax plus b equal to c. You want to find the value of x because x is constant, or we can say x is the variable or the unknown quantity here, whereas a, b, c are the constants. So to find x, first you have to transpose b to the right hand side. As b is added on the left hand side, it will get subtracted on RHS. So it will just get subtracted from c on RHS. Okay, so this will give you some d. This is the difference of c and b. Next we have ax is equal to d. You have to find x, so we'll transpose a from LHS to RHS. As a is multiplied to x on LHS, it will get divided by d on RHS. This will give you value of x or the solution of the unknown quantity or the unknown variable x, which is e. So let us solve one problem to understand this. Let us solve the equation 4 into t minus 5 is equals to 9 using the transpose method. The given equation is 4 into t minus 5 is equal to 9. Now, the variable term on LHS is t, and we are going to transpose first 4 to the RHS. As it is multiplied on LHS, it will get divided on RHS. So we have t minus 5 is equal to 9 by 4. To get only variable on LHS, we transpose 5 because we want only t on LHS. So minus 5 will be transposed to RHS. It will get added to 9 plus 4, 9 divided by 4. If we add these two fractions, so how we are going to do? We are going to make the both the denominators same. So we have to multiply 4 to both the numerator and denominator. So you have 5 4s are 20. So 20 plus 9, 29 by 4. Hence the solution or the value of the unknown variable t is nothing but the solution of the given equation is 29 by 4. I hope this session was helpful. And after the scholarship test, that is RMS Ramanujan Math Scholarship, if you want to continue to use Counting Well app to keep learning maths, practice and improve your scores and develop good problem solving skills, then you can download the app from the App Store or Play Store. Also, stay connected to our channel Counting Well. We will see you in the next live session on 27th April at 5 p.m. with different chapters, that is number system, maths application, mensuration. Until then, keep learning and keep growing. Thank you.